Hello everybody. In this video we'll be covering one of the sections in chapter 7 of our textbook entitled Chemical Reactions. In this video we'll be discussing gas evolution reactions. So reactions in which the driving force is the production of a material that escapes as a gas are called gas evolution reactions. Some reactions form a gas directly from ion exchange. So an example like that would be like this equation here, where we're exchanging the ions just like we were doing in our precipitation reactions and our acid-base reactions, and the resulting material that we get out just happens to be a gas at room temperature. Other reactions form a gas by the decomposition of one of the ion exchange products into a gas and water. So an example like that would be like this ion exchange, where we produce this sulfurous acid. Sulfurous acid is not stable. It tends to break down into liquid water and SO2 gas. Compounds that undergo gas evolving reactions. So any one of these are going to tend to break down to produce a gas. So this is a handy table that we can kind of reference later. So if you have a metal with sulfur or a metal with hydrogen and sulfur on it, and you react that with an acid, you're going to tend to form H2S. H2S is a gas at room temperature. This is actually the gas that's trapped in water that gives it that like eggy taste or smell, if you've ever seen it. This is not due to any kind of decomposition or anything like that. And the gas that's formed is directly H2S. And here's a little example. We have a metal, potassium in this case, in combination with sulfide. We react it with HCl and we produce H2S gas. Whenever you have a metal with CO3, so we've been calling these carbonates so far, and we react that with an acid, you're going to form this carbonic acid. It will decompose down into CO2. So an example of that would be like potassium carbonate with HCl, and that's going to break down into CO2 and H2O. Like Tums is calcium carbonate, and that tends to react with the HCl in your stomach, and then you kind of belch or burp after that. It's because of the production of CO2 that's happening. A metal with SO3 or sulfite polyatomic, react that with an acid. Again, we're producing HSO3. It does decompose, and it decomposes down into SO2 gas. And another one would be our ammonia. And then you treat that with a base. You make ammonium hydroxide. We said that this is like our cleaner, and that's going to tend to decompose and produce ammonia. And that's why like the cleaner smells, because it's ammonium hydroxide in solution, and it's decomposing slowly, producing this ammonia gas, and that's what you're smelling. So determine what, let's go through the process for predicting the products of a gas evolution reaction. First thing we're going to do is determine what ions each aqueous reactant has. Then we're going to exchange those ions like we've been doing so far. We'll balance the charges to make sure that we have neutral species. We'll check to see if either product has the H2S in it. And then we'll check to see if either product decomposes. So to see if it's one of our decomposition guys that we've seen in the previous table. If so, we rewrite as H2L and the corresponding gas that we should see. And then finally, we're going to balance the equation. We should also be checking to determine the solubility of the other products so that we can correctly write what phase they are going to be in. So let's try one here. We have sodium sulfite and we were going to add that to nitric acid. So two things are keying me in that this is going to be a gas evolution reaction. Number one, we're reacting with an acid. Okay, so now I know that we have something going on here. Let me back up here. If we had a base and we were reacting with an acid, I would think that this is an acid-base reaction. Because we have a metal bound to a non-metal, we're treating a salt with acid in this case. I'm going to start to think that maybe we're talking about a gas evolution reaction, okay? Because there's not really a good reason why a salt would react with an acid in any other situation. I can see that we have our SO3 in here, so I know that that's going to play in the end. So we'll start off by determining the ions present when each reactant dissociates. So we dissociate these guys and we dissociate this guy. Then we exchange the ions as we've been doing. And then we're going to write the formula of the products. Remember to cross our charges, make sure that we have a neutral species. When we do that, we get sodium nitrate and H2SO3. Sulfurous acid. Then we're going to check to see if either the products is H2S, because that would be a gas, right? The answer is no. Then we check to see if either product decomposes. Yes, this was in our table, sulfurous acid. We know that it decomposes down into SO2 gas and water. We replace the H2 or the sulfurous acid with these decomposition products, SO2 gas and water, and we have our final molecular formula. The only thing that we need to do is we need to check to see if this is going to be soluble or not. Oh, actually, first we need to balance our equation, right? We're going to see that this is a guy that has two charges with two sodiums, so we're going to have to put a 2 here to make everything balance out. Put our 2 there. And then we know that sodium nitrate has sodium and nitrate, both of which compounds that contain those are always soluble. So we know that this is soluble, and we're going to write our aqueous after it. And we get our final reaction that we should be seeing. We can do a little bit of practice now, and I'd like to see if you guys can predict the output from these two reactions. You can pause the video and I'll give you a second. So for this one, we had lead sulfide. What I'm looking for here that keys me in that this is going to be a gas evolution one is that it's a sulfide bound to a metal. We're treating it with an acid. We get out lead sulfate plus H2S. We know that lead is generally insoluble, even though sulfates are usually soluble. Lead is an exception to that, so it's a solid. And H2S is a gas at room temperature. For the second one here, we have an acid with sodium bicarbonate. We know that the carbonates, CO3 and HCO3, tend to produce gas, and we get out sodium nitrate, and then that H2CO3 is going to produce CO3 and water, or CO2 gas and water. Water will be in the liquid state. Sodium nitrate is soluble because both sodium and nitrates tend to be soluble.